We're going to talk about where our protons, neutrons, and electrons are in the atom. We're going to also learn their relative charges and their relative masses. So protons, neutrons, and electrons are things that make up the atoms, and most of you are familiar with this. You've heard of these things. So we do need to know some basics about them. So in your notebook, you should have this information. So protons are here in this first column. They are located in the nucleus. Now, comparatively speaking, they are pretty large particles. Their charge is +1, and we use a P with a little plus sign. That's kind of my symbol. You may not see that everywhere, but that's what I use. Neutrons are also in the nucleus. Again, they're fairly large as well. Protons and neutrons are about the same size. Neutrons are neutral. They have no charge. And so we use an N with a 0 to represent them. Now, electrons are not allowed in the nucleus. They hang out in energy levels around the nucleus. Compared to protons and neutrons, electrons are extremely tiny. So if we think about an atom being the size of a football field, the protons and the neutrons would be like ping pong balls in the center. I mean, they would be not too big, and they would weigh almost nothing. Electrons would be like a speck of dirt compared to the ping pong balls in the stadium. So comparatively speaking, protons and neutrons are going to be more massive and larger than your electrons. In a lot of cases, we consider the electrons to have no mass whatsoever. But it does have a charge of -1, and so we use an E with a -1 to abbreviate it. Now, this is a computer simulation. That is one of your tic-tac-toe squares in your tic-tac-toe board. It's called Build an Atom. And what we can do is we can see what happens when we take a proton and we add that here. We have hydrogen. Okay, so on the periodic table, there's hydrogen. Now, we can also add a neutron, and we can add electrons. Okay, now typically your hydrogen's not going to have any neutrons. It's just going to have a proton and an electron, but there are cases where the number of neutrons would change. Now, if we add 2 protons, notice we have a helium atom. Okay, it's unstable as well, but look what happens with the electrons. All right, we put the electrons in. Notice they're situating themselves far away. Now, we can make this a stable atom by adding neutrons. Okay, that helps with stability. Let's see if we add another proton in here. We get a lithium atom. All right, now we have to add another electron. Let's try to put it here. Notice we can't do that. It has to go out into the second energy level. Let's see if we can make him stable. All right, so the protons and the neutrons are going to go here in the middle in the nucleus. Your electrons are going to go on the outside. If we add another electron and another proton, notice adding the protons changes our element. Okay, there we go. And the number of protons in here, we've got 4, 1, 2, 3, 4, typically matches the number of electrons for a neutral atom. And that we'll talk more about that in a different learning target. But your protons and neutrons are here in the middle. Notice that their size is much larger than these little tiny electrons out here.